You want to see a neat trick? Check this out. Here I have this yellow balloon. I want to increase the volume. What am I going to do? Put it in a vacuum chamber? Put it in the microwave? How about this? Just add more gas to it. Welcome to molar volume and gas stoichiometry. So, isn't that a fascinating trick? I bet you guys are all fascinated. I can tell, especially you guys, period 6B, you guys are just as fascinated as you are at everything. So that's cool. That's all right. And anyway, here's how we're going to use this. Obviously, if you increase the amount of gas you have, you increase the volume. That's what this law says. And there's all kinds of other variables that go into this. And we know now that volume can be affected by pressure, volume can be affected by temperature. We're not going to mess with any of that. What we're going to say is at STP. And you guys all know what STP means. If you haven't been paying attention, I'll remind you, standard temperature and pressure. And for us, those are going to be 1 atmosphere, also known as 760 millimeters of mercury, also known as 101.3 kilopascals, and also known as 0 degrees Celsius, but you can't use Celsius in these calculations, so you got to get it into kelvins. And so here's what we mean by this. At STP, and here's where I need you to be paying extra attention. At STP, 1 mole of any gas. When I say any gas, I mean any gas, occupies 22.4 liters. So let's get that into your skulls. 1 mole equals 22.4 liters at STP. And we're not going to be doing any calculations for anything other than STP. So what this means is that we can calculate what volume a gas would occupy if we knew the moles. So here's an example of a question you might expect me to ask like that. So here is the kind of question you could expect me to ask. What volume would 3 moles of oxygen gas occupy at STP? All right. It doesn't matter what the gas is. So we could say, what volume would 3 moles of occupy? It doesn't matter, okay? So we're going to say, how many moles, well, it's oxygen gas, but we're not really concerned with that. How many moles of oxygen gas would be equal to 3 moles? Oops, I'm sorry. It's asking for volume. Let me back that up. My computer is doing something weird, and now it's refusing to erase. So that's cool. We'll just go like this. Well, let's try this again. What volume, how many liters of O2 gas do we have if we have 3 moles of O2 gas at STP? And remember, it doesn't matter what the gas is. It doesn't matter. What we know is that at STP, 1 mole of any gas, O2, hydrogen, helium, is 22.4 liters. So let's bust out your fancy schmancy calculadora. Here's mine. Let me turn it on first. That helps. Oops, that's an AP chemistry problem. You don't want that. And we're going to say, and remember, when we set this up right, moles cancels moles, leaves our answer in liters, and we're simply going to say 3 times 22.4. How many liters can we expect 3 moles to occupy? 67.2 liters. That's all you do if you're going the other way. Let's try one that is asking us to go backwards. It would look like this. All right, and here's one going the other way. How many moles of CO2 are present in 50 liters at STP? Remember, 1 mole equals 22.4 liters. It doesn't matter. As long as we're at STP, 1 mole is always going to occupy 22.4 liters. So we're going the other way. We're asking for how many moles of CO2 would be present in 50 liters of CO2 at STP. We know we are going from liters to moles. Remember that whatever you're starting from is what goes on the bottom. 1 mole is equal to 22.4 liters. Thank goodness for calculators. And we're going to say 50 times 1. We're not going to do that. We don't need to. Divided by 22.4. How many moles do we have? 2.23. Now, what can you do with this? Here is the type of question I'm going to ask you guys to be able to do with this, and this is what we're going to call gas stoichiometry. So don't panic. It's going to look weird. It's not. Let's take a question. Okay, this is a good example of the type of question we could ask with this, because we know that at STP, that's supposed to be highlighter, sorry, erase. Oh, my computer is taking its time. Hang on a second. Okay, good, it erased. So here we go. We know we're at STP. How do we know? It tells us that we're at STP. It says what volume of NH3, that's this stuff, could be produced from 4 moles. Darn it. Give me a second here. Okay, I think I got this working now. So we are trying to find what volume of NH3 this stuff could be produced from 4 moles of H2 at STP. You're probably going, what? Remember, 1 mole equals 22.4 liters at STP, and that's all you need to know. So when we set one of these up, it's going to look like this. How many liters, excuse me, hang on, I'm trying to get this to erase. Wait a minute. How many liters of NH3 would be equal to 4 moles of H2? Now, what do we know? We know that according to this equation, there's already a ratio of moles. It's right there. The equation's already balanced. And we could say, all right, well, we want to go from moles of H2 to moles of NH3. Well, the equation's right there. That 2 goes there, that 3 goes there. And since we're not trying to find moles of NH3, but we're trying to find volume of NH3, well, we're at STP. That means 1 mole is equal to 22.4 liters. So I'm going to get fancy. I'm going to multiply across the top. I'm going to divide by the bottom. I'm going to multiply across the top and divide by the bottom. So here we go. Bust out my fancy calculator. And we'll say 4 times 2 divided by 3 times 22.4. And we don't need to divide by 1, but we'll do it anyway. How many liters of NH3? 59.7. If you wanted to round that up to 60 liters of NH3, you go ahead and do what you do. Okay? That's all you do. Some of these questions will ask you to go from liters to moles. Some of them will ask you to go from moles to liters, and some of them are going to ask you to do some stoichiometry, but they're not that crazy. Okay? Take it for a spin. And be safe in the snow.